Welcome to qnawire.
Problem 11.35. So we have a cube made out of copper. It's sitting on a table, or actually it's been glued to a table with very strong glue. And then we imagine a force acting on the top of this parallel to the table. It's horizontal. First, we want to argue or show that the glue is exerting a force that's equal in magnitude and opposite in direction to the force we're applying. And I haven't even written anything for this, both because that would be a lot of writing, and also we're not going to write anything down to answer that, because the reason is the cube's not moving when we do this. And so from the first, from the conditions for equilibrium, the sum of the forces has to be 0, and this is the only other thing that can be exerting a force, so it has to be pushing back on the bottom of the cube with an equal and opposite amount of force. So B, so this is going to be a shearing type of deformation. So it'll start to look like a parallelogram instead of a square. And we want to find the force required to deform this by 1/4 millimeter. So this is the area times the amount of deformation times the shear modulus divided by the height. So this works out to be 6.6 times 10 to the 5th newtons. Now, if we make the same size cube but out of lead, how much is it going to deform under the same force? So for this, we just solve this equation for x instead. So this is FH divided by the area times the shear modulus. So it's going to deform by 1.8 millimeters. So you can see that lead deforms a lot more easily than copper does, which if you've ever, probably not very likely to have gone around pushing on pieces of lead, but you know that it's a fairly soft material, and so although the softness has to do with plastic deformation and these are elastic deformations, it makes sense that it would deform either plastically or elastically much more with the same amount of force than for something like copper.